grade 8s or grade 9s, whoever is watching at the moment, welcome back to a new year, 2025. I really hope that it's going to be a prosperous, wonderful year. And I thought it well to make a video just on something that the students really struggle with and that the teachers always start with at the beginning of the year. So it's something that you just need to understand logically. So we are going to look at the real numbers system, how numbers came about. Okay, so as you can believe, long ago, people had to they naturally wanted to count stuff. They had to bring up a number system, and they started with the natural counting number, which is 1. So when they taught their babies, this is 1, however, what language they spoke, they had to create a system as to saying these are numbers and this is the way we count. Okay. So I want to break it down so that you understand it completely. So if you are grade 8, I know that we don't necessarily delve into the irrational numbers, maybe not even the non-real numbers, but it's something to holistically understand, and then you can just delve into your little portion that makes sense to you or that you are busy with. Okay, so let's get started. Right, to start off with, you've got real numbers and non-real numbers. So let's start with the smallest one, is the non-real numbers. So a non-real number is a number that is not real and is also known as an imaginary number. Non-real numbers are numbers that have an imaginary component, which is the result of taking the square root of a negative number. So just to quickly explain that to you, if you've got a square root, let's say the square root of 16, the way you would find those answers in just a simple way, you will say to yourself, what times what will give you 16? But the what and the what must be exactly the same number. So 4 times 4 gives you 16. All right, so why they say that you cannot have a negative under a square root is because when you change this to 2 negative 4s, remember the numbers must be exactly the same, and it's now a negative 4. A negative 4 times a negative 4 will always result into a positive 16. Why is that? It's because a negative times a negative will give you a positive. So never ever can you have a negative under a square root. Okay, so that is your non-real number. It's the only one you need to focus on now, or it's the imaginary numbers. At university, you'll delve deeper into that, but at school level, that's where we'll leave it at now. Okay, so just please remember, never ever have a negative under a square root. All right, can you have a negative under a cube root? Of course you can. So if you have a negative 27, you can indeed have negative 3 times negative 3 times negative 3, because a negative times a negative will give you a positive, and that positive times a negative will result again in a negative. So negative under a cube root, that's 100%, but a negative under a square root, it's a non-real number. All right, so now that we've looked at what is a non-real number, let's look what are real numbers. So real numbers can be subdivided into 2 categories. You get your rational numbers as well as your irrational numbers. Okay, so rational and irrational. Rational numbers we will look at, and in grade 8 we actually just focus on this little section over here. So I'm just going to highlight it quickly. We're just going to focus on that rational part. But in grade 9, then we add the irrational number and we look at it holistically. So I think from grade 8, just spend a bit of time and see how does the whole number system fit together. I think it will stand you in good stead. Okay, so irrational numbers, I always remember it as the 2 impies. So the 2 impies, and I'm going to explain to you now what I mean with my two impies. So impy and impy, and the digit pi. Okay, so pi is a number. We use that, it's a value that we use with the circumference of a circle or the perimeter of a circle, and we always use it in terms of pi. Okay, so what that means, it's a decimal number that doesn't stop and it doesn't have a pattern. So if you think of pi, if you put it in your calculator and you press the, let me just quickly put it in here, your S to the D button, you'll see it's 3,1415926 and it carries on and on and on, and it actually never stops. So I remember at school we always used to have, I'm sure you do as well, at Pi Day they look at who can remember the most pi digits. Okay, so it will carry on and it doesn't stop. So irrational numbers are decimals that carry on and on and on, and it doesn't stop. So you might think that there must be only a few of those. There is more irrational numbers than rational numbers, believe it or not. Okay, so what do I mean with the two impies? It's when you've got two imperfect square roots. Okay, so you've got an imperfect square root. So think of the square root, of 10. If you punch it into your calculator, the square root of 10, you will see it gives you 3,162277766, and it will carry on and on and on without ending. So to understand the imperfect square, let's look at what is a perfect square then. If I say to you the perfect square root of 16, that will give you a beautiful answer of just 4. Or the square root of 25, those are perfect square rootable numbers, and that would give you 5. Okay, it gives you one answer, where the imperfect will give you lots of digits and it carries on and on and on. Think of the imperfect cube root as well. So if I've got the cube root of 6, so then it will be a decimal, it will carry on and on and on. So if you think of a perfect cube root, will be like the cube root of 27, which is equal to 3, or the cube root of 64, which is equal to 4. So those are all perfectly square rootable numbers, and that would be then a rational number. But the irrational number will be the imperfect square and the imperfect cube, as well as pi. Okay, so just make that summary so long, and then we're going to delve into the rational numbers. Okay, so those three are your irrational numbers. Okay, so the rational numbers, let's think of it rationally. All right, so remember when I spoke to you about the people from the olden days, right back when they used to discover like bones with little stripes on to see how people counted, and they actually discovered prime numbers that was written out, where long ago people realized that there's something special about prime numbers. If you can't remember what a prime number is, let's think of 2, 3, 5, 7. What makes those so special? 11, 13. It's numbers that are only divisible by themselves and 1. Okay, so long ago, people already realized these are very, very special numbers, and that every number is made up out of a product of primes. Okay, so, but let's think of it rationally. Like I said, there's this little baby. So when you are a little baby, what does your mom how does she start counting with you? She starts counting 1, 2, 3. No mom will say, this is -5, and if your brother doesn't pay you back, you're going to have -6 rand, and you owe, blah, blah, blah. No. We start with natural numbers. So when you're a baby, I want you to think of the natural numbers. Okay, so that is the first number that would be rational. Okay, natural numbers are rational numbers. So natural numbers, the way you would represent it with sort of like an N like this. Sometimes it has a little double stripe depending on what the computer does with it or how. Okay, but it's represented. Let me just try and get it something like that. All right, with the N. It's natural numbers. So what are natural numbers? So think of when your mommy starts counting with you, she starts counting. This is 1 block, 2 blocks, 3 blocks, 4, 5, 6. And depending how good you were, it goes on all the way to infinity. Okay, so those are your natural numbers. It comes naturally to you to start counting 1, 2, 3, 4, 5. All right, and then you get a little bit older and you get introduced to zero, the hero. I remember with my kids in pre-primary, they introduced the zero to actually say that there's a number that represents nothing. So that is what we call whole numbers. So whole numbers, and I want you to double check very nicely, is natural numbers with a zero added. Okay, so it's all the natural numbers as well as a zero. So it would be 1, 2, 3, 4, 5, 6, and carry on. Okay, so now the child's getting better. We're introducing them to whole numbers to actually represent that there's a value, a number that represents nothing. And now we are progressing to the next set of numbers. And can you think what those are? Yes, those are your integers. I hope you've guessed correctly. All right, so integers, S, normally represented by a Z, integers. Now, so because now integers is every single number. So if you have a look at this number line, it's everything on here and carrying on. So it's -10, -8, -6, -4, -2, 0, 2, 4, 6, 1, 2, all of the numbers in between. But do you see any decimals on here? Do you see any haha? I always call it the haha numbers. Think of before we started adding fractions and things like that. We don't see any of those. So integers are your beautiful numbers, positive and negative. Okay, so let's quickly think. So you get introduced to these as you hit maybe grade 6, grade 7, or maybe even earlier. Hey, you're like, oh, I've started long ago. So it comes in from negative infinity, -4, -3, -2, -1, as well as your whole number 0, as well as your natural numbers. Okay, so it's an integer is everything, every beautiful number, whole numbered answer, or whole numbers with negative and positive, if I can say that how would you say that like directly. Okay, so let's quickly think. We've got natural numbers, whole numbers, integers, but now we also get fractions. So all of these three, your natural, whole numbers, and integers, are all rational numbers. They all belong to the rational number group. So maybe I must put a line all around, all around like that. Okay, so those are all your rational numbers. Then we also get the fractions. Okay, so they are also they are also rational numbers, but very, very important. The fractions have to have an integer at the top as well as an integer at the bottom. Okay, so rational numbers also contain your fractions, which has an integer at the top and an integer at the bottom. Could also be a negative, because an integer can also be a negative. So just please remember every number in between. Okay, so if your teacher gives it to you as a decimal, let's say it gives you 1.2 recurring, that will actually be, if you had to put it in your calculator, 1.22222222222, it will give you 11/9. So you can always test it and say, do I have an integer at the top? Yes, I do. Do I have an integer at the bottom? Yes, I do. So that would be a rational number. Okay, if ever you need to think, is it rational or is it irrational? Remember, irrational is the two impies, imperfect square, imperfect cube, and pi. Okay, so rational numbers also have your fractions. Let me put this in purple, just to stick to our color coding. So it also has fractions, but very important, the fraction must have an integer as a denominator as well as their numerator. Okay, and that is your number system. So let's have a look at how your teacher will assess this in your exams or in your tests. All right, so this would more be in grade 8, I would say, perhaps grade 9, but more grade 8. So you always have to simplify. So they say simplify the following and then classify the simplified number. Okay, so we need to go and classify it and see where would it belong then. Just want to make this smaller. That's it. Okay, so first we're going to simplify. 3 plus 5 is 8. There we go. What types of numbers? So I always think, obviously, it's a rational number. No? It doesn't belong to the irrational numbers. So is it a natural? Is it how your mom would start counting? Yes, it's a natural number. It's a whole number. It's an integer. And thus, because it belongs to all of that, it is a rational number. All right. So do you able to classify? So 3 minus 5 would give you -2. Is it a natural number? Does your mommy start counting -2, -1? No. Is it a whole number? It's natural numbers with a 0 added? No. Is it an integer? Yes, it is. And because it is an integer, it is a rational number. You'll see in grade 9, test more whether it is rational or irrational. So then we take it a step further. So 3 plus a half. If you had to simplify that, you can write it as a fraction. 7 over 2. Oh, sorry. Now I'm doubting myself. 7 divided by 2 is 3.5, which is 3 plus a half. There we go. All right. So it's not a natural. It's not a whole. It's not an integer. Remember, those first 3 are beautiful numbers. This is a fraction. But now, if it is a fraction, can we see that it's got an integer at the top? Yes, it does. And does it have an integer at the bottom? Yes, it does. So thus, it is a rational number. Okay. Simplify, square root of 25 is 5. So thus, it's going to be a natural, I'm going to copy and paste over here. It's a natural whole integer, which makes it a rational number. Same with 16 over 8. If you simplify that, it gives you 2, which means it's a natural, whole, and an integer. Okay, the cube root of 64. First, we need to simplify, and that would give you 4, and 4 is a natural, whole, integer, and which makes it a rational number. Okay, then, just when we add under a square root, if it was a multiplication, then you are welcome to go and do them separately. So if it was a multiplication, then you could have said, what is the square root of 64? What is the square root of 36? And then multiply together. But because it's an addition underneath, we need to first add the 2 underneath the square root and then square root my answer. So the square root of 64 plus 36 is 100. Which gives you 10, and again, that is a natural, a whole, an integer, and thus it's a rational number. I'm just going to make it, a little bit smaller over there. All right, so it's a bit of simplification as well. All right, over here, when we've got a cube root with a mixed fraction, we hate mixed fractions. We never ever like them. So we're going to turn that into an improper fraction. How do we do that? We say 3 times 8 plus 3, and that would give you 27 over 8. And remember, we haven't taken the cube root away yet. We just simplified inside or underneath the cube root. And how that works is we're going to cube root the 27 and cube root the 8 both. You can split it, you don't have to, but what that means is you cube root 27 and you cube root the 8. Okay, and that would give you, let me just see my color here. So it will give you 3 over 2. All right, and that, let's see. All right, so it's not a natural, it's not a whole, it's not an integer. Let's have a look. Is it a rational number? Does it have an integer at the top and an integer at the bottom? Yes, thus it's a rational number. All right, then number I and J, just a bit of bed mass. Some of you might know this as bod mass. It will change soon where we start teaching you about bed mass, where exponents come in. But let's quickly see. So your brackets we're going to do first. 7 minus 7 is 0, and 0 times 2 is 0. Over. Remember to do the multiplication first. You're more than welcome to put brackets around there. 3 times 2 is 6, and 6 plus 3 is 9. 0 divided by 9. A 0 is fine to be on top. Okay, so 0 at the top is exi perfecti. It just always your answer will be 0. So that is, let's quickly classify them. Is it a natural number? No, but it is a whole number. It's an integer, and thus making it a rational number. All right, then let's quickly have a look. Always your multiplication first. 6 times 2 is 12. And 6 minus 12 gives you negative 6. And at the bottom, 6 times 6 is 36. Minus 2 is 34. Now, is it an integer at the top? It's a fraction. So we're going to ask, is it rational? Is it irrational? Integer at the top, integer at the bottom. So thus it is a rational number. Okay, I just want to make sure 6 times 2, I've done this one. There we go. Okay, then something I just want to add, very, very important. When we've got a fraction, and although you're going to say, but both of them are integers, the only time when you cannot have an integer as a fraction is when the denominator is a 0. That is a no-go. Okay, so when the 0 is under, it is undefined. Okay, so I always used to teach my kids, when the 0 is under, it is undefined. Very, very important going forward. When we've got x's that we work with, and people, we can never ever divide with a 0. So if I've got 3 over x minus 1, what can't x definitely not be? X can't be 1, because if I replace that x with a 1, do you see that I will end up with 3 over 0, which is a no-go zone. So please, 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 as we go forward, grade 10 especially, when we start using fractions and x's in our denominators, you must always make sure that you double check that x doesn't have a value that creates that the denominator, or that equals the denominator to 0. Okay, so very, very, very important. All right, so we're almost at the end, and this is where we get to where this is more grade 9. Okay, so if you're in grade 9, I want you to carry on watching this video. If you're grade 8, if you feel like watching, please do. It's really easy. And so grade 9, please be aware that we want you to say or to classify a number then. Is it rational or is it irrational? So all of these are real numbers. Remember, they're all real numbers. Real numbers get split into 2 categories where we've got rational and irrational. Okay, so irrational, just remember quickly, It's your imperfect squares, like the square root of 10, the imperfect cube, which is like the cube root of 14. There's lots of them, as well as anywhere if you see pi in your little creation, it will be irrational. Rational is if we can simplify it and we can have a fraction with an integer over another integer. Okay. Or just, like the natural number, remember, so it can be your natural numbers, your whole numbers, or your integers. Okay, so let's quickly see. We're going to be quick. Is the square root of 8, do you think that's a perfectly square rootable number? Most definitely not. So if you square root 8, if you put it in your calculator, you'll get 2 square root of 2. But then if you press S to the D, it's going to give you 2.828427125, blah, 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 blah. So this is an imperfect square, which will make it an irrational number. Okay. Remember what I said with addition? You have to first simplify underneath, and then the square root of 16 is 4, which will make it a rational number because it falls under the natural, whole, and integer, which makes it then a rational number. Okay, the cube root of 9, is that a perfectly cube rootable number? If you don't know, you can put it in your calculator. The cube root of 9, it gives you 2.0800838, blah, 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 blah. So definitely this is an imperfect cube, which makes it an irrational number. Okay, then remember to simplify underneath first. So this is the square root of 3 times 8 plus 3, which gives you 27 over 8. Can I square root 27? Can I square root 8? No. So this is an irrational number. But can I cube root this? Can I cube root? So it's exactly the same. I'm just going to take the previous simplified answer. Can I cube root it? Yes, it will give me 3 over 2. And do I have an integer? Yes. So this will be a rational number. And remember what I said, anything with a pi in between will be irrational. You don't even have to go and stress or worry. It will be an irrational number. All right. Okay, people, I really, really hope that you've learned a bit, or you've learned, and did you understand? I just want to bring us through to this where I've simplified it over here. I know it might be a little bit small, but there is your summary. And then something I really want to add is that if you have a fraction with a 0 underneath, it will be undefined. So it doesn't belong to a real or non-real. It's anything divided by 0 is undefined. Okay, I really, really hope it helped. Good luck with the beginning of the year. Do your best. And if this video helped, please share, that your friends can also benefit from this. And as we go throughout the year, I will be making more to keep you up to date. So all the best with the year and lots of love from me. Cheers, everyone.